Okay, good morning. So I'm doing another I guess early morning recording so that I have enough time to go over some cool stuff that's uh, that's upcoming here. And I love it because I like making tools, and this is like something I've been excited for. Just to know how to do better, which is it looks like we're going to parse command line arguments properly. So like if you ever wondered whenever you run a program, you have these little switches here, right? Like how does the program actually take these switches correctly and handle whatever values coming after them? Is this always something that intrigues me because I always thought that like we would have to kind of iterate through, let's say, this argv array one by one and handle them in like a very messy way. But from what I'm seeing here, it looks like it'll be pretty straightforward that it's actually handled for us. So let's see what we have in store. So let the library do the work for you. Many programs use the command line options. So there's a special library function you can use to make dealing with them a little easier. It's called getOpt. And each time you call it, it returns the next option it finds on the command line. So just to remind ourselves, these are options, these hyphen. So there's a convention to it. We call them options. I call them switches sometimes, but I think the proper way is to call them options. So let's see how it works. Imagine you have a program that can take a set of different options. So we have two options here, an E option and an A option. So this E option is to say how many engines you want, right, for this rocket. And A option is the awesomeness mode enable. Okay, sure. Um, This program needs one option that will take a value -e, which is engines, and another one that is simply on or off -a, so a boolean. So one is a number, takes in a number, and the other one will take in a boolean, which is basically if it's on, meaning that the mere existence of it means that it's true. So without this switch or without this option, it means it's false. Awesomeness is false. So you can handle these options by calling getOpt in the loop like this. So we need to include this header. This is the Unix library, I guess, UniSTD. So Unix standard library, not C, but Unix. So it gives us a lot of Unixy things. Um, so we use getOpt, right? And we pass in argc, which is the total number of arguments we have, the argument vector or the argument array, so an array of all the argument strings, and then the options, so the type of options we have. So A, E, and then colon. Okay, so the colon means that, I think it's telling C to expect some value after E. So E, every time you have E, expect some value, like parse that value. So in this case, 4 here. A doesn't have a colon because we say the mere existence of it is actually meaning that it's true. So no values after it. Otherwise, if there's a value after the A argument, the A or the A option, then there would be a colon. So it would have been A colon E colon if we expected something after A. Okay. So the colon means that the E option needs an argument. Okay, cool. So how we do this is it's a while loop that probably kind of, it's like, like a queue, right? Where getOpt will give us back the next option to consume, and we can just have a switch statement here. So if we encounter E, then opt_arg will contain the value following E. Okay, and then we do this, and at the very end, right, we subtract the number of options we read in with the values we read in from argc, and then we also add, I guess, to argv, which is a pointer. We're doing pointer math, right? The number of characters and values we've consumed. Okay, so that makes sense, right? Opt-in is just like an offset. Why do we need that? Because actually, if we were to kind of digest this with get opt, this loop here really looks like it only goes all the way up to here. And so we need to move our argc all the way, well, we need to move our argv all the way up to right here so that we can actually take in the rest of the command line arguments that follow, right? Because get opt only consumes arguments and the values after it. In this case, there's no value after A due to this specification here, so we don't expect anything, right? Everything after here is just the rest of the arguments that you pass into your program. So options are digested through this loop up to that certain point. Then you have to do some math to kind of update. For example, I've read in 3 arguments, right? So I had to now say argc only has, if we started out with 7 arguments, now we only have 4 arguments left, for example, right? And if we do that, we have to update our character array pointer down, like push it all the way forward so that we can actually start at the right place this time. So inside the loop, you have a switch statement to handle each of the valid options. The string AE colon tells the getOpt function that A and E are valid options. The E is followed by a colon to tell getOpt that the -E needs to be followed by an extra argument. So that's what the colon does. The colon tells us that there needs to be something else following the option. An argument, basically. GetOpt will point that argument with the opt-arg variable. So opt-arg and opt-ind, these are hard-coded, right? So they'll be updated for you at your convenience. So whenever you encounter E, since there's a colon right here, the C compiler or whatever that's running, right, the library code will actually put in the value into opt-arg, and then you can actually access it there and save it into your own variable. So you get opt-arg for free, it looks like. When the loop finishes, you tweak the argv and argc variables to skip past all of the options and get the main command line arguments. So these are the main command line arguments. Now argv0 becomes this, argv1 becomes this, and argv2 becomes this. Whereas before they were 0, 1, 2, 3, 4. Brasilia was 4, but now becomes 0. Tokyo was 5, but now becomes 1. London was 6, but now becomes 2 because of this math here. We moved the base address down, whatever opt-ind was, right? So that now this becomes, wherever this was, becomes a new base address. So here, we will now be able to parse out the rest of the arguments the way we would normally do it with argv. So here's an exercise. It looks like someone's been taking a bite out of the pizza code. Can you see if you can replace the pizza slices and rebuild the order pizza program? So let's see. Okay, so we had to use all of this. Why don't we just code it? Let's code it for practice, right? So yeah, let's create a project. So we'll call this pizza args, maybe. Okay. Let's see, post all. Pizza args. Okay. I just remember I'm in Vim mode now, so let's just copy this, and it's good to just type things when we're still new. include uni_std.h. So that's the new library we can use to parse command line options. So we'll have int main, int arg c, and then we'll have character pointer arg v, an array. Okay, and then we'll have character delivery. Okay, so a character pointer, I like to do it like this. A character pointer delivery, so a string in thick, I guess that's the thickness of the pizza. Count, I guess that's how many slices of the pizza. And char ch, I guess that's the command line option that we're going to parse. And we'll have a loop, right? So while we can still get something from the command line, so get opt, argc, argv, and d is basically delivery string. And I think we need also something that follows it, right? So it's something like this maybe. And then we have thickness and count. So is it something like this? Something like this? Let's see. Do we have D? So we have T. Is it thick? Oh, this is confusing. Okay, I guess we're on our own here. Let's just try it. So while we can get a character, and then we have to check it's not the end of file. Okay, so basically get opt returns us a character, right? And eventually, we have no more character or no more options to consume. Character ch will eventually be EOF. Okay, that's just like a special value, -1. It's defined to be -1. So whenever get opt returns -1, that's going to be ending this loop. And that means we do more stuff here and return 0. Okay. So let's see. We're gonna do switch ch. So we'll switch whatever character. Case D. I guess we can say delivery equals, I think it's opt arg. Great. It's opt arg, right? If we looked at this one, opt arg. Okay. And then case T. Oh, I guess we only need T. Okay, so it's D and T is the only thing we need. Okay. Why is opt arg undefined? Huh. Strange. We'll see. Case T, we'll say thickness. Thick is opt arg. Break. And then default, we're gonna print to std error with fprintf. Remember, that's a way to redirect our std error. Unknown option %s. We'll quote that with a new line opt arg. So we don't know what that is. Okay. Oh, return. We don't break. We return what was it? Return 2? That's what we were supposed to do for errors. Okay. So now this part here, we had to, out of the loop, we always do some math to opt in D to kind of say we've consumed this many, I guess, arguments, right? And then also we had to move our argv up forward by that amount. Remember, we're doing pointer math. This is moved by number of bytes, right? And this is just a pointer. So I'm guessing this is also maybe a pointer, right? We had to probably get the address of this maybe. but we'll see. So, and now, if thick, meaning if thickness, if we have something, a number, we, or maybe not a number, maybe it's just the existence of it. Interesting. Thick crust. And then if delivery 0 to be delivered, delivery to I guess to be delivered to who? Confusing. Printf to be delivered string s, new line, delivery, and then at the end we'll say puts ingredients then we'll just kind of put the rest of the ingredients out from the argv array. So basically, the rest of the arguments that follow after the options get printed. So for count, so count is this for the loop. Okay, so we're writing more modern C, so we can confuse ourselves less and just say int count here, because count was defined all the way up here so that we could use it in this for loop. But I'm just going to define it down here instead, because that makes me so confused. So count is less than argc, right? So we want to argc is going to be the new number of arguments that we have. So we want to loop or iterate through the rest of our argv list, right? And we can tell when to stop because argc will tell us how many remaining arguments we have left. And then we'll do count plus plus, and then we'll just print argv at count. Then we'll return 0. Okay, so it says identifier opt-in D is undefined. Why is that? I want to see. Let's check out uni std. Maybe there's something here. Oops. So let's try to find that opt-in D. Okay, it's not there. How about opt-arg? That's not there either. Huh, that makes me nervous. Does that mean we did something wrong? Maybe it's not what we thought it was? Well, let's compile and see what happens. Because I thought we got this for free, right? This opt-arg thing. But here it's telling us it doesn't exist. I thought this would have included it. Same thing with opt-in D. So yeah, let's compile and then we'll get a bunch of errors and we'll see what happens. Yeah. Okay. So pizza args gcc main.c. So we're here. Assignment to int from character pointer makes integer from pointer without a cast. Oh, okay. So opt-arg is going to be a character pointer. Assignment to int from char. So do we do something like a to I to make an integer? In order to do that, we need to include stdlib. Is that how we do this? We might have to look at the answers. Okay, that works. Oops. So we do what? Dash D, hello, and then dash, what is it? T, thickness 3, and then I don't know, pepperoni, pineapple, anchovies. Yeah, that's a really interesting combo. So we have thick crust to be delivered hello, ingredients, pepperoni, pineapple, anchovies. So it looks like a program works, but I just don't know whether or not like that's exactly what they wanted. because we have count 0 here, count argc here, and then we probably have return what? Return 1. It looks like that's what they wanted instead of 2. And then case t thick. Oh, they probably did thick is 1 instead if the thickness exists. So we probably didn't need to pass in a number. They probably wanted something more like this, and then thick would be 1, and then they probably wanted like this. Either you have thick crust or not thick crust. It's probably not a measurement. It's probably just this where thick is 1, and then that looks about right, right? D colon T. So colon will be here, T would be here. D delivery would be opt arg, thick would be 1, and this will be return 1. It's probably like this. I thought that thickness was like a measurement of the thickness, but really it's just either it's thick or it's not. So that's why we don't have the colon here now. Originally I had it like this because I thought it was like some sort of number that we were expecting, but I think this is fine. I think this is what they want. So yeah, let's just check it out. Let's just check the answer. So yeah, exactly. Colon T. So they didn't expect that. Delivery opt arg thick 1, return 1 instead. And then here 0 and arg C. So yeah, it's exactly what we thought, but I just don't know why like opt arg and opt in are said to be, I guess, undefined. But I think I would ignore that because I think we are just using an extension like a C++ or C extension. So yeah, it compiles just fine, right? So we did this, we got no errors, right? And I think that now 3 would be determined as an ingredient. So we did this, yeah, ingredients is 3 now. So then we didn't have the thickness T. We don't have thick crust to be delivered hello and then ingredients here. Okay. Nice. So I have earned 3 points at my gym. I have fit perks now. I have no clue what to use it for. 3 points. Oh, okay. Good to know. Um, okay, so here's how they used it. They tested it hard. Look at this. So it said order pizza, anchovies, pineapple. So no ingredients. Oh, let's do that. Hey, I also chose anchovies and pineapple. We have good taste. Okay, so let's do this. A that out. Anchovies, and I can't spell. Let me. Anchovies, pineapple. Okay, and then we'll have D now. Oh, to be delivered now. That's what they mean. Okay, that makes sense. Dash T. Okay. And then what happens if we did, what is that? Option requires an argument. Oh, sorry. Like this. Option requires an argument. Okay, unknown option. No. No. Right there. Okay. Hey, it works. All right, moving on. So it works. Well, you've learned a lot in this chapter. You got deep into the standard input, standard output, and standard error. You learn how to talk to files using redirection and your own custom data streams. Finally, you learned how to deal with command line arguments and options. A lot of C programmers spend their time creating small tools, and most of the small tools you see in operating systems like Linux are written in C. If you're careful in how you design them, and if you make sure that you design tools, excuse me, that do one thing and do one thing well, you're well on course to becoming a kick-ass C coder. There are no dumb questions. Can I combine options like -td now instead of -d now, -t? Yes, you can. The get opt function will handle all of that for you. Oh, really? Let's see. -td now, pepperoni. Oh, that's so cool. Okay, so we can actually combine them and it'll read just fine. How about if I did this instead? Because I think D is the last one. If I did DT, to be delivered T, it read the option as D, and then since it's programmed to look at the argument after D, it read T as that delivery string, right? Right here, T D colon, right? And that will be here, so delivery. So that doesn't work. DT doesn't work, but TD works because -T. So I think this is distributed, right? This becomes -T -D, and then you have now. But if you did -DT, it'll be -D, and then right after that will be -T, and it'll read that as T most likely. Okay, that's how I'm reading it. So that doesn't work, but this works because now comes after -D. Okay. What about changing the order options? Oh, wait. Because of the way we read in options, it won't matter if you do -D now, -T, or -D -D now, or -TD now. Okay. So that's what we found out. As long as you have something coming after -D, it's fine. So we could do something like this: -D now, -T, or -T -D now. Right? So that works. Thick crust to be delivered now. Okay. So if a program sees a value on a command line beginning with a dash, it will treat it as an option. If it reads it before it gets to the main command line arguments, it will, yes. But what if I want to pass negative numbers as command line arguments like set temperature -C -4? Won't it think that 4 is an option, not an argument? In order to avoid ambiguity, you can split your main arguments from the options using --. So if you you would write set temperatures -C or -C -4. Get opt will stop reading options when it sees a --. So the rest of the line will be read as simple arguments. So you have to read this manually yourself. You don't get it for free, apparently. Okay. So there are two versions of the main function, one with command line arguments and one without. But we always like to use this one, the one with command line arguments. Command line arguments are passed to main as an argument count and an array of pointers to the argument strings. Command line options are command line arguments prefixed with dash. Okay. The get opt function helps you deal with command line options. That's really useful. It's just that this is kind of like, at first weird to read, but you have to kind of evaluate this from the inside out, right? So get opt, we do, let's say, man get opt. So get opt is used to break up and parse command options, okay, but what is the return value, right? So the return value, parsing, blah, blah, blah. Let's see, return. Okay, return codes. Get_opt returns error code 0 for successful parsing, 1 if get_opt returns errors, or 2 if it does not understand its own parameters, 3 if an internal error occurs like out of memory, and 4 if it's called with -t. Okay. Guess that's it. Hmm. So return 0. Wait a second here, though. But that's assigned to ch. So am I looking at the right thing? Let's see. Get opt. Blah blah blah. Parsing out. Oh, output. Output is generated. Quoting, scanning, compatibility, return codes. I guess. I guess because other values would be the character itself. I guess. Sure. So EOF is basically then going to be -1. Okay. So somewhere down the line, get op will return eventually -1. Well, it's not equal to -1. So basically when we keep parsing, we're gonna get -1. If character is assigned to -1, so -1 is not equal to EOF -1, then we don't execute the loop. Or if it's one is not equal to -1 is not equal to -1, that is false. So we don't execute the loop. Otherwise, when we have stuff, we're gonna just keep going through. Okay, so out inside out, confusing, but okay. Ah, all right. So we finished another chapter, but before moving on, I kind of want to start maybe like a long-term project that we can do, right? Using what we already have with C. Like, here's what we know how to do. We know how to manipulate strings now. We know how to take in command line options. We know how to print stuff to the screen, and we know how to redirect that into a file. We also know how to get input, and then we know our basic functions and pointers. I think at this point, like, we have the ability to do ifs, switches, loops. We actually know a lot. We've come pretty far. I think we know enough to try and work on a project together. Um, I think I think we should start really small because I also have no idea. Um, and I want to stick to something that I'm familiar with, but use like C. And it sounds silly, like, but I kind of want to make like a static site generator, like a just like a web page, right, out of C. So like, can I like given some text files, take that in, right, and combine it into like an HTML file, and then have that render out, and then can we somehow script to kind of host that file, like probably upload it or something, so we have our own personal web page. Maybe let's try it, right? So like it's just, it's gonna be very simple. Right now we're probably gonna just generate a simple web page. Then we're gonna move on by making it customizable, like having a few files around and then kind of stitch them up to make a single HTML, and then we'll move on from there. So yeah, we'll come back to this chapter after we get something working. But for now, let's first commit the code that we have. Pizza arts. Okay. And then let's create like maybe project 1. And let's actually make a main.c here. And let's start a template. So I just want to create like a web page right now that um, just has a title and a simple paragraph. So the title will just say hello world. And then so let's just say, um, oops, title will be hello world, right? And then our content will just say, welcome to my new personal web page. Happy face. So that's why our web page will be simple for now. So we should probably just say, uh, builds a web page that has the following content. Okay? And so we'll just start. So include stdio.h, int main, int argc, character argv, and then we'll return 0. Okay, so let's actually pretend we don't know anything for now, and just to remind ourselves, basic HTML. If you have problems with HTML, you're not familiar with it, I recommend you going to this site here. It's just easy, fast tutorial to learn HTML. So I still don't know why I date my stuff. I need to get out of that habit. It doesn't mean anything. Okay? Learn HTML. It's a free resource. Okay? Huh? That's weird. I'm in insert mode. Am I hitting the wrong keys? Paste? Weird. Wait, what's paste? Control V. Oh, I keep hitting Control Shift V. Wait. Oh. I'm too used to Control Shift V. Okay. So. Okay. That's one. So. We know that headings. Let's see here. Yeah. Headings is just like H1, H2, H3, and so on. So right here, heading 1 with the H1, heading 2, H2. So simple. We'll just say printf H1 hello world. And we'll do a new line. And then we'll also have our content, which is going to be a paragraph. Okay? I'll just assume you guys kind of know this. I don't want to go from the very beginning like that. So what's our content? Welcome to my new personal webpage. Webpage. New line. Okay? And let's make it proper HTML. Let's just do something like this. HTML. New line. Printf. Head. New line. Printf. Title. My website. And this will eventually like be generated. And then we need a close. Okay. And then we'll have a body. I know this seems silly, but just bear with me. We start out small, right? This is like a test to see how good we are with printf. I would even say all this can be puts, right? So let's actually change that right now, since we're not even doing any formatted strings here. So we do, I guess, replace. So we're gonna find. Ooh, what the heck? No, that's not. Wait, is that what we want? Let's see. Find and replace. We'll do printf with puts. Okay. And that's it. That's our basic web page. And let's see, the goal is to see if we can compile it. So cd project 1. And then we do gcc main.c, a.out. So we have a generated web page here. So HTML head, title, head, body. Okay, so how is this even useful, right? Like, also puts actually will deliver us a new line automatically. Oh, that's why everyone uses it. Okay, I'll do it like this. Ah, okay, I'll do it like this. I think that's better. So cool. So we have this simple web page, but what do we do with it, right? Like it outputs this to our screen, but we want it as an HTML file, right? So what's the first thing we should do? We should redirect this output to an HTML file. So we can just do something like a.out, take that output and put it into a file called index.html. If we do that and we do ls, we'll see we'll have index.html. So then we can go to our project, actually open it up, then project one. We could double click on this and we're able to actually see our web page. Pretty cool. So that's it. Like that's it for today, right? So we can build on top of this slowly.